Started the recording. Today's workshop will be led by Victor, our application engineer and expert. Any time when you have some questions, you're welcome to send a message to support@quicksurface.com, and we'll do our best to answer. This is the part he will go through today, which is, from my point of view, is quite complex, but Victor will show us how easy it is. The reason I'm talking so much is just to see if there will be more people to join, but I don't see anyone in the queue. Whoever comes later, I will let them in and they can join. Please allow Victors to go through the process. If you have any questions, put them in the chat, and then at some point we will stop for Q&A session and we will answer your question. If it's something super critical, Victors, please allow me to interrupt you. I'll
Yes,
try not to do this, but it's a workshop. It's not a webinar. So the more questions we have, the better. That's the main idea of the presentation. Okay, now over to you, Victors, and feel free to start.
Yeah, thank you. So yeah, basically we're going to reverse engineer this part, and as we see, it's like curved in several directions. So we have curved surface on top, like visible surface, and the back surface is in like different curvature. So it's kind of, let's say it's conical shape if you're looking from the side. So today we're going to take a look how to use like freeform surfaces to achieve this result easily. And before we're starting, I just want to remind you that you are always welcome to share your ideas and some struggles, maybe what parts you are struggling to recreate, just for like ideas for upcoming online workshops, what you would like to see here and what you would like to learn from these workshops. Basically, this depends on you what kind of content we are creating, but as we discussed with Costa, probably upcoming 1 or 2 online workshops will be related to freeforms and probably automatic freeform. So something like that. If you have ideas, just feel free to contact us in Facebook group or just write to support@quicksurface.com and we will discuss everything and we'll try to help you. Well, I guess we can start. Let's open raw scan data. And as always, we are going to try to align this to our coordinate system, more or less somehow. A bit more difficult with parts like this. But as we can see, we have some more or less planar surface here in the middle. So I'm going just to use this spot to align this to top plane. So let's go to segmentation, drag our slider. Oh, yes, probably something like this. So just select some segments of mesh. And let's see the result. Yes, okay, this is pretty good. So, and essentially we don't have too much nice geometries where to fit some planes to use them for alignment. So I'm just going to use sketch entities for this purpose. Drag the sketch plane a bit down to get some feature lines. And this looks good. And see what do we have here? That's probably I like this edge. And actually, this is more than enough for this part. So click OK. We have one plane, one edge, and we'll just align this part to coordinate system. So actually, we're going to align by coordinate system. Select plane as primary feature, flip direction, and secondary feature. I'm going to use this line from sketch. And as you see, this line will define like X direction axis. Apply. Let's see how it looks from top. Good. So it's perfect. We can close this and let's hide our sketch. From this point, we can start to reconstruct our file. First of all, I'm going to use new freeform. For that, let's add our plane. So it's new freeform. Why is it cool? It's cool because you can adapt it to nearly any surface, depending how dense network you're creating. In this case, we're just going to create a simple network. Like I would say it's super simple. Let's start with creating first quad. We can switch on tolerance display. And let's set it to something a bit finer. And from this point, we can start to expand this. By default, in your software, you will see this D button if you select your edge. So you can come over to this edge, press on D button. This will automatically let you create another quad. Now I'm with a node of this D button appearing, so by default it's off for me. So what I'm doing, I'm using Alt key, press Alt key, select your edge, drag it, and it results in the same result as there would be. Use this D button hotkey, I don't know how to call it. So, and for easier operation, in some cases, we have a pretty cool shader. So this indicates more red regions in some corners or fillets, so we can estimate more properly how far we can stretch our freeform surface without going onto the actual fillet. Well, in this scan data, it's a bit rough, but still we can find and see these feature lines pretty okay. So let's just drag it more, and probably a bit further away, like this. Here. Here. Up to the end. Same on this side. Like this. Okay. Adjust these regions. So yeah, according to this color plot, you see how easily we can recreate this shaped surface. And in this case, we need this surface to be much bigger, so we can actually use this as a surface for trimming of our solid. And in order to do that, we can use extrapolate tool. But before that, Well, actually, I will just show you the idea behind my next step. Let's try to use extrapolate. So we can extrapolate this surface to another direction, third direction. And here you can see that it's getting a bit distorted. In order to avoid this, I'm going to switch off snapping mode. And with local manipulator, I'm just going to stretch it out to make it a bit more uniform here and here. As you can see, we still have this green deviation plot in all necessary places, so everything is absolutely fine. And from here we can, just extrapolate this again. So this way we can create our surface way larger than we need. Then it's essentially on our scan data. Okay, close. We have our first surface created with deviation of 0.0 something. In worst part, we have 0.13, 0.17. So it's under 0.2 millimeters. So it's super low. Okay, so now we can hide our first surface and let's actually create our first solid extrusion. Should be about time. In this case, I have examined this part previously already. And here is some catch on it. And we can come over to this region and create our sketch, enable clipping. And as you can see, here is our top plane. It's horizontal completely right now. But these side walls, they are at different angles. On the right side, we have, actually, we can measure what do we have there. So basically, let's fit a couple of lines in our scan data. Like this, and here we can see on one side we have 79 degrees. On another side, it's 89 degrees. Basically, if we're doing extrusion typically is normal to our sketch plane. So that means it will go completely vertically, and even if we are using draft, we won't match these surfaces. So to fix this problem, I have created these two lines that represent angle of these surfaces. I'm selecting both of them, creating a red line in between them. And this part I'm going to use, not part, but this line is going to be for our upcoming sketch that we're going to use for extrusion. And at the same moment, this line will be normal line for extrusion direction. So, okay, we have completed the sketch. We can exit it. We can come over to 2D sketch. Select pick button, select this line, and our new sketch is perpendicular to line from the sketch. Actually, this is what we needed, and considering this part is it's so different angles everywhere, we can try to do it like two ways. If we have enough geometry here, probably we can create sketch at this level. Let's just experiment. Essentially, who is not still familiar with fitting entities, you can come over to extract primitive button and manually select lines, not lines, but mesh sketch points, because when sketch is created, we are receiving these mesh slice points at the intersection of sketch plane and your scan data. So you can select them, and then come over here, quick fit line. Another option is instant fit, so you can just brush over these points and software will automatically fit line. But another option that is like, let's say, more advanced, you can use hotkeys. So if you hold Shift button and drag around these points, it will fit line or arc or circle. So software will detect it by itself. And at the same moment, if you're holding Control and brushing over to endpoints of line, it will automatically connect these two lines at intersection. And if we're repeating this section on the same corner, it will automatically create fillet based on mesh data. Yes, actually, we can create fillets everywhere also, so we have less job later. This is 5. I'll quickly create some more lines. Here we have like 2 different edges. Three of them. So what do we want to fit here? Let's see. Good question. So let's just try to fill it. Way too much. Looks like it's small part. 3, 5. Work like this. So I have to create some additional geometries here. I'll just fit another line here, connect everything. Try to go this way. This way. Well, here we're doing the same. It was good enough. And another cool thing, if we select here line, for example, you want to draw some line that would snap to splice points, you can hold Control button and it automatically snaps to these points. In many cases, it's useful. For example, it's here. So you cannot actually select some mesh points right here because you just don't have them, but you can snap your line to these points. Yes. Well, more or less it looks. looks just fine, and seems we have filled everything. Okay, let's try to do extrude. And this part we're going to extrude higher than we need and lower than we need. So basically we're going to use this as a prepared block. Okay, what do we have here? So let's see our sketch again. Okay, we have some problematic spot right here. So let's repair it. There should be an extra line we don't need anymore. Both of them are sliding right now. Mhm. So some intersection of the lines here as well. So let's take a look at this region. Yes, exactly here we have another problem. Actually, let's try just to trim it. Then again. Okay, now we have correct result of our shading for closed loop. So now it's absolutely fine. Okay, so we have our first solid, so we can hide this. Maybe not yet. Let's keep it. So let's unhide our freeform. We can select solid in the freeform to do our first trim. Okay, this way we have created our top surface of our part. So to proceed, now we need bottom surface. To create bottom surface, we're repeating same operations with new freeforms. One quad, another quad. By aligning them, bending another side. Yes, it looks very well. Now we can do the same actions as in top surface, so let's make it more uniform. Something like this, and now we can proceed to interpolation. This, this. Perfect. Now we can unhide our solid and trim the bottom side of it. So this way we have created main surfaces of our part. But at this point, we see that our side edges, not edges, but side walls doesn't match the actual cam part. So in order to fix this, I'll just go back to extruded surface, extruded solid, and I will add some draft for it. Pretty much. Okay, let's file it 4 degrees. What do we see here? Okay, so now it's way better. We have just left only fillet on one side, and on the other side, this side is a bit further away. Basically, more or less due to the fact how we created our slice sketch. So actually we can go and edit it a bit to match better tolerance on this side, but for saving time, I'm going to just skip it right now. So let's add some fillet here. And at this point. Basically, we have failing fields pretty often where we have super close and small faces. And probably these are the spaces that are making problems for us right now. So let's try to get rid of them quickly. Just where at the moment. Make that fillets from here. Right, fill this again. Nope. Okay, this time this is interesting. Probably you'll have to spend a bit more time to find the actual reason for this. But before that time, I think I will just go to next features to show you a bit more how to create other geometries, and later we can come by to take a look at this filleting. So in this case, we have cutouts on bottom side with some ribs. And we have these two features sticking out of our part, and they are not completely aligned to top surface of this part. So let's hide this one. Let's create another plane. At least let's try to fit it there. Adjust our segmentation. They're absolutely planar. That's good. Okay, so create. Let's start sketch from here. Let's now go to middle of this cutout. Create, and I'll just hide sketch for now. And I want to explain one thing. Here we can see on this scan data that we have perfect surfaces vertical on this side, and on this side it's a bulge. So most likely there was some issue while scanning, but here we had some missing scan points, so it just filled the holes with some kind of surface, and in this case it's bulge, same as we see on this side, and same we have here. One side is nice and square, and this side is bulge on this side as well. So let's fit some entities here, and as we see here, we also have this weird result. This side is really nice and a really nice looking plot. So let's try to fit clearly plot here. Say bounce and fill. So it points and click on slot. Let's block this side. And it. Right. Let's make these two lines parallel. So we can actually on this side. You can try to lock this one. Manipulate it this way. So here we have pretty close aligned to our edge, and we can lock this. Drag this side down just a bit, and we're going to align our slot according to mesh slice points on this side where we didn't have bulge. We'll just drag it back. Okay. Drag this side. Now we can take a look at what dimension do we have here. So it's 7.55, but in this case we don't have matching. We have matching surfaces on the corner, but it doesn't match here. Here we have some similar situations, so let's get rid of this and let's try to make it a bit larger. This now it looks better, and it should be now closer to 7.7, so most likely maybe even 8 millimeters. So let's try this out. Oh, the 8 is maybe too much. So let's try it 7.8 and 7.7. A bit weird dimensions, but well, who knows? Maybe it is like that designs, or probably it comes from from states with imperial sizes. So let's say it's 7.7, and on this side we're going to repeat the same operation. Let's hit slot. Actually, in this case, we can try to select all these points. Hit slot. Or not. Try again. Yeah. Okay, so let's select it. Oh. Fine. This actually I already insert dimension 7.7. Okay, so this would be our first feature. Let's extrude this. Okay. And more back, enable visibility of our fitted plane. Let's create another sketch. That would be outer surface of these features. 8. And this time I'm not going to fit another slot everywhere, but I'm going to use previously created solids. Actually not solids, but I'm just going to use their sketches. And there's two buttons, project, other visible sketches, where we can come over to our previous sketch, just select entities. And these entities will be copied to your new sketch. And at this point, I'm going to select complete loop and offset it to 2.5 millimeters. Let's repeat with this side. Yeah, perfect. So let's make extrude. Let's snap one side to our plane. And disable snapping. Bring back our solid. And make sure that our extrude is completely intersecting the top surface. Okay, we can hide our plane, and here let's select combine feature. Okay, good. Now we can hide our sketch. Let's bring back these two features, and we're going to use them as the cutter tools to complete our cutouts on this part. Great. So let's see how this looks in comparison to our mesh. Oh, we're pretty close. Let's try to create fillets here. Um, Well, 0.8 looks pretty good. But create and stay, and let's now select the bottom parts and see how it goes here. Well, it's something 1.15 is good. Okay, so we have top surface more or less done. So let's get back to bottom surface. Kind of solid. So we can see that most likely here we are going to have just uniform thickness from top surface. So that means we will need to offset the surface. How can we do that? And one of approaches, we can just come over to our first freeform, click on duplicate. We have another surface. Now we can come over, edit it, switch off curvature shader. So we have green tolerance analysis map on the actual top surface. Let's come over and flip this surface, go back to edit. And now we have analysis plot on opposite side. Here we can come over to this button. We have offset option here. So it's 2.5. Let's try this out. Okay, it's not completely. So let's make it 2.7. 2.7 looks actually really good. So it's absolutely green. We can close, and this surface we're going to use to create these cutouts. At this point, we can hide it again. And now we can unhide our second sketch. Let's create another slice based on this data here. Let's try to align something. Okay, this should be more or less good enough for now. So now quickly, let's fit line here, fit line here. For example, maybe these two as well. And now I would like to, again, repeat copying process of previously created sketches. Or maybe not sketches this time. This time probably you can use our solid. See, what do we have here? We have one line here. The line here. Okay. We can hide solid right now. And we can hide this sketch as well. Again, we come over here. Let's make offset. And this looks like more 2.9. Set. Let's select these two. This side probably 2.8. 2.7. So we see that we have different thickness of walls. So now we can come back and to delay these two lines. And let's create intersection of them. This. And like this. We can extend these two lines. That. Use our trim tool. So we have two regions here, few loops, and I think I'm not going to create anymore during this session because we're a bit limited on time. So let's make extrude. Like this, like new solid. Let's unhide our offsetted freeform. Let's trim these two parts. So we don't need these top parts and these bottom ones. Okay. Bring back our solid. Again, we're repeating cut from solid to solid. Select our cutters, and we have these indents here. Then bring back our mesh. Oops, wrong side. I'm sorry. Basically, get rid of this cut. Let's set the trim. Let's set it. I'll get rid of these sides. Okay. Repeat. Okay, done. So this way we can achieve these cutouts with uniform thickness of the top surface. And here we have some more things to do, way more things to do. We need to create extra widening here, but this would be actually absolutely the same as we created these top features. So we can just use the same sketch, offset it as much as we need, and create cutting surfaces the same way. But at this moment, I would like to stick to fact how we can create one of these clips. Maybe this might be more interesting. As I see this clip, for example, well, we can stick to any of them.
Sorry to interrupt you, Victor.
Yeah.
What you're saying is that when you do reverse engineering from the beginning, it's really hard to start and do everything at once. What you show here is that you need to do step by step, create the outer and then add material or remove material. So you kind of split the problems into smaller problems. Is that what you mean? You know, step by step and
Yes, of course, we have to do all the things step by step, just because if you will fit here a lot of different features and planes and everything, and we'll try to trim them at once, it will be a huge mess, and you won't be able to find all the small surfaces that are within the solid that will actually restrict software to create this as a solid. It will be as just a surface body. And yeah, so basically when you're doing some reverse engineering, do it step by step. So at the first, we created our first solid, then we cut it off like top surface of it, then bottom surface, and now we came back and created these indents here. So basically, from this, you would have to create now several more sketches and just repeat the same actions to create another of these indents. But just to save time and not repeat the same actions, I'm going to show how to create, for example, this clip.
But
so
just limited in time. Maybe we can stop for now and ask the audience for questions before you begin. And
yes, of course, it's a good idea. I will have some drinks.
It's good if we listen to the audience. So feel free to ask. If you want to unmute yourself and ask, this is just a normal workshop, or you can type in the chat. Anyone have any questions? No? Okay, there are no questions, so you can carry on and just show what the next
Hi,
step.
everyone. Sorry, there's a question in the chat, and I have another one. Could you just give us a quick high level, logic when here we have a part that has some that is mostly parapipedic, so there's a lot of flat surface and everything. But if we were to work with more complex surfaces, could you maybe walk us through a little bit the total logic? Would it be freeform, then extract some primitives, then generate some sketch again, build some volume, or would there be other strategies that you would use still using the same tools?
So, well, it basically depends on part that you want to replicate. So if you have some examples that you are talking about, maybe of your own scan data library, you can share this with us and we can take a look at your part. But more or less strategy, you fit one kind of surfaces. For example, here we used like freeform, then we use sketch to extrude all this solid, then use this freeform to cut surface. Basically, one by one, you are recreating everything, and there is no like high level strategic. You have to take a look at every part by yourself and try to understand how it was created or how it was modeled previously. So here you can see that there was surface, and on top of the surface were added these slotted rings. You see that there were added some fillets, and same as on opposite side. Basically, there is logic how you imagine process of this part was modeled, and it's up to every person how he, maybe not every person, but this person's like experience with CAD modeling and how he sees that process, and of course part itself.
Yeah, one of the challenges for reverse engineering is I read this on the social media. A friend of mine, he said, I spent 90% of the time trying to understand how exactly this has been done. And then in 10%, you just start building this shape. So every project, like Victor says, is individual. You need to understand how it has been created, because the reality is these are not manually created parts. They have been created with the CAD software before that and manufactured. And this is where you need to apply your strategy to rebuild this.
Well, yeah, basically it depends on part, and it depends on your experience and how do you see this part on your vision overall. So
Yeah, so I guess maybe to clarify a little bit, and maybe here the clip area will help me understand that. But I'm basically trying to rebuild some complex surfaces for car parts that have been damaged, for example, and there's not any surface on that is not curved, right? Everything is a complex shape, right? And so to be able to scan accurately and then to rebuild the surface, it can be quite complicated. So this is why I was wondering if you had like for more like free type surfaces with multi curvatures, if you had a strategy to do that. But maybe here in the clip, we're gonna have some areas that can be demonstrated.
Okay, at the end of this workshop, I can show you material from this different workshop. Probably that might be more related to you, but otherwise, if you are using Facebook, just head up to our group and maybe post some pictures of your scan data, and we can discuss it there and probably make some demo for you. So,
Okay, sounds good. Thank you.
okay, so let's proceed with this. What I want to create. I want to create actually extrusion from, let's say, from this view. So in order to do that, I'm going to fit plane here. And I'm going to fit another plane here. Okay, so and now I'm coming to construct the reference line. So let's construct the reference line based on these two planes. Okay. Good. Now we can find these planes. Let's again create 2D sketch and use this constructed line as a guide for our sketch plane. I want to use probably this profile here. Create sketch. Yes, we have here one line, and another one. Back side of clip, bottom of clip. Just quickly connect all of them. This. What I want else? Let's see. Probably I want some part of this as well. This. Let's get a closed contour. Let's extrude this. For example, way more than we need. Something like this, yeah. Okay, let's keep it as a separate feature right now. From this, probably we can use this top plane to define another sketch. No, actually, not this plane, but let's use this plane. Create it. And here. Yes. We'll basically extend by outside of our solid. I'll do the same on this side. Okay. Extrude. Intersect solid completely. Okay, and now we can select everything. Trim some parts of it away. Okay, solid body. Now it starts to remind some shape of clip. And on this side, we can come over to our first sketch of clip to drag this line more to the bottom so it extends more. After this, we can duplicate our second freeform. Okay. We can use this surface to construct plane form selected cut face. Okay. Let's hide our first freeform. Let's hide our mesh. Let's extend this plane. And now we're going to initiate another trim. It is. Actually, it won't work like this, but cancel everything. Let's try a different way. Okay, we can create single surface from this. Actually, the problem is that we have like coplanar surfaces here, and currently we have trimming issues when we are having situations like this. So let's come back to this sketch and let's pull this inside as well. Now we can do the trim. Solid body. Well, as you can see now on the bottom, it matches the same surface. And we can actually come over and combine these two parts. And we have uniform surface. Oh yeah, but this is just a part, and at this moment you can realize how much time it takes to like reconstruct small pieces like these clips and just small features that in normal life looks like it's nothing, but yeah. For example, we have here a lot of different fillets, and we still have here like some poking part of this clip, and well. Basically, to recreate this clip completely, you will still have to create at least 3 to 4 sketches. But well, yes, considering that we are running out of time, probably we can create just a couple more fillets here and there, just for better visual representation. Okay, so yes, basically something like that. Fortunately, we don't have enough time for completing all this project, or maybe if users want, we can suggest options that we can take some project and split it, for example, in 2 parts, like we did today. This half, and like in next online workshop we can continue with the same part to complete it, or we can just take a look at another example. So basically it's up to you. And overall this part
Yes, as I know it gets bored after an hour, so I think we covered most of the principles of how things should happen. Again, we invite everyone who has questions to join the Facebook group and put the questions there, or if you want a personal attention on specific questions, I see one in the chat as well. Don't be afraid, just contact us. We'll do our best to respond. We're always for this.
Okay, so in this file, when I was testing it, so you can see that here you have to add some more geometries and fill it here and there, and same with this tab. So all this is doable, and same with these cutouts. Well, just it takes time. And if we are talking about different kind of surfaces, let's see, I think it was this one. So basically this is material for probably another online workshop where we can use freeforms and see advantages of them. So basically here we have fitted a bunch of different freeforms. Later all that is being trimmed one to each other, and we end up with one complete surface.
Yeah, we wanted to keep this
everything.
but Victor just showed you what the next topic will be. As you can see, this is completely different application. Reverse engineering is so broad and so complex and so many different projects, and everything needs to be addressed individually. So yeah,
Well,
join our next webinar workshop where we'll show you how to do this.
yeah, the reason I showed you probably this application more corresponds to the question that we had previously about some different approaches of using this. So maybe this reminds more his project, and so this is the reason why I showed this. But yes, this is going to be a topic for upcoming online workshop. So join us next time. What else can I say? If we have some questions, we can answer them. But what do we have?
I would like to say a big thanks again to Victor's for the workshop, and I would suggest that we finish for today. If you have any questions, contact us and we'll keep in touch. Thank you. Thank you very much, everyone. Thank you and have a good day and evening. Bye-bye.
Thank you. Bye. See you.